Hello, I'm Dr. David Riley, and today I'll be presenting an online lecture on meta-analyses and systematic reviews. So I'm going to give you an overview of this online module. It'll introduce you to the statistical technique of meta-analysis. You'll learn how and why they're used in psychology and how you can benefit through the contributions they make. You'll also learn how systematic reviews contribute to psychology as an evidence-based science. Now, it's designed to be self-paced, introducing you to these topics in smaller, bite-sized chunks. I get that stats isn't for everyone, so we're going to go nice and gently. And the idea of making an online module like this is that I don't overwhelm you too much with stats and equations and those sort of more abstract concepts, and instead try to teach you how meta-analyses are used and how you, as a psychological consumer, can use a meta-analysis. Now, alongside the online lecture component will be a number of exercises for you to complete, as well as some associated readings. It is strongly advised that these are attempted to maximise your learning. No, I won't, no, but for you to get the most out of this course, and particularly this topic, it's strongly advised that you do attempt these learnings, and that way hopefully it will reinforce the concepts, and it might just be something that sticks in your mind and that actually is used one day, something that has some practical benefit. Wouldn't it be nice to have a stats course that you could actually use? Okay. So let's go through the basics. What is a meta-analysis? Well, a meta-analysis is a statistical technique that integrates the results of many studies across different samples, time points, and research teams. It does this to provide an objective estimate of the size of a psychological effect or a particular treatment or intervention. Why is it important? Well, there's a few reasons. Firstly, it provides greater confidence and precision than can be found with an individual study or even a series of experiments. But it also helps identify important moderators of the effect that wouldn't be apparent from a single study. Why is it important? Well, there's a few reasons. Firstly, it provides greater confidence and precision than can be found with individual studies or even a series of experiments. And the other reason is that it helps identify important moderators. These are things that affect the outcome of interest that wouldn't be apparent from a single study. Now we're just going to go through an overview of some types of evidence in psychology. I think most students will be familiar with the individual study. It might be a randomized controlled trial, it might be an experimental study, it might be quasi-experimental. You go out to an organisation or a company and you measure a particular association between two variables. Now, sometimes you'll have a significant effect, and if you do, you've got a greater likelihood of being accepted for publication than a study that's just reporting null findings. Of course, sometimes too it might be a fluke. You might just get lucky, or the effect that you're trying to study might only be found under certain contexts. So before you accept the conclusions of a study, you obviously want to have a look and see whether it replicates across different types of samples, across different types of measurements and different types of scenarios. And you can use the technique of meta-analysis then to combine the results, to pool all those studies together and try to come up with some objective measurement of how big of an effect it is that we're looking at. That's generally fine, provided that it really is a comprehensive view of all the available literature. Sometimes, just sometimes, you'll come across a meta-analysis that's a little more selective. They discount certain studies that maybe don't support their hypothesis, or they omit other studies for a variety of reasons. And because of that, we needed a better, more objective way of reviewing the literature. And that's where the systematic review comes in. The systematic review provides a higher standard of evidence by examining the entire body of literature. It makes clear what the inclusion and exclusion criteria are and provides a snapshot of the research literature at any given point in time. And each of these techniques provides a greater degree of confidence and a greater degree of precision than you would find with the previous. So a meta-analysis provides a more comprehensive view of the literature than a single study or even a series of replications. And a systematic review gives you the confidence and sort of feel-good assurance that it really is a complete view of the literature. So let's go through and examine the individual study. Imagine for a moment that you're looking at a particular psychological effect, perhaps the association between two important psychological constructs, or maybe the effectiveness of a particular intervention on an outcome. Did it help? In undergraduate psychology, you will have been introduced to the concept of significance testing. Remember good old P less than 0.05? And you'll also have learnt that there's a possibility of a type 1 error. But that's very rare stuff, right? And we've only got a 5% chance of it happening. Not going to be a problem. And you also know about the rigorous process of peer review as a safeguard, and that researchers never take shortcuts or employ dubious methodology or data collection. So the individual study, although it might seem impressive at face value, because you don't get to actually see the data, you haven't performed the analysis yourself, and you don't know whether it will generalise, individual studies don't provide a great degree of evidence. Now that might not sound controversial because it's been published, but the barrier to publication is actually extremely low. What a lot of researchers will do when their work is rejected at more prestigious publications, they will just work their way down the list. And so to some degree, the peer review process and the fact that an article has been accepted for publication, it represents both academic effort and hard work, but also a little bit of luck and a little bit of persistence. So individual studies are incredibly problematic. They may lack statistical power and fail to find an effect. That's what we would call a type 2 error. They often lack random selection and employ a convenient sample. Now this is typically a research subject pool, but it could also be patients in your clinic, employees in an organisation that you have access to, and so they may not be representative of the general population. There are likely some very important moderators affecting the size of the association that you're looking at, or the group differences, say, between treatment and control. Now, the intervention, it might also be poorly described. It might be idiosyncratic to the individuals conducting it and missing the secret active ingredient responsible for change. Or they may be employing a non-standardized version of the treatment. So if you take something like cognitive behavioral therapy, we know that there are many flavors. There's mindfulness-based cognitive behavioral therapy. There's a variety of techniques. There's online administered CBT. There's face-to-face. And all of these are potential moderators that will affect the size and the magnitude of the effect size. The other problem is that the original data is rarely published, and it may hide a multitude of sins and shortcuts. Now, because you don't have access to this, you'll never know what shortcuts they took. So you should always be skeptical with individual studies. You would want to see whether they replicate. So rather than relying on a single study, as practitioners, we should consider the results of a series of studies before reaching a consensus about a particular topic. As psychologists, we need to be able to weigh up the evidence ourselves. Now, a challenge to psychology as a field is the replication crisis. If you haven't heard of it yet, I guarantee that you will. So the replication crisis refers to many intriguing and novel, these are euphemisms, by the way, for suspect studies that fail to replicate when independent researchers attempt to do so. So this article here, which I provided as part of your readings, it is an article on estimating the reproducibility of psychological science. It was published in one of the most prestigious scientific journals we have, Science, and I would imagine that initially the researchers did not anticipate the effect that this study would have and the ripples that it would send throughout the psychological community. We'll cover that in a moment. Now, initial studies, particularly of shocking or surprising, more euphemisms, they should be interpreted cautiously. Consensus comes from combining a variety of studies on an effect to see if it generalizes across samples. But you might also be time poor, and so you may rely on the expertise and knowledge of others who have written a review of the topic. Now, if it's a good review, written by competent professionals who are completely objective, then it might be safe to accept their findings. But often, what they present is a narrative review. Now, a narrative review just presents their opinion or their general impression, and it's usually of a selective subset of studies rather than the entire body of literature. And the argument that they would make is that they're providing quality control, they're using their expertise to show you what particular studies are important in the field and what can be discounted. Problem is that it's a highly subjective process, and you're effectively outsourcing your critical reasoning. So I mentioned the issue of the reproducibility crisis in psychological science, and you may be wondering, just how serious an issue is this? Well, it depends. It varies by field of psychology and also on the topic of investigation. If it's a very narrow and niche topic that only a few people are investigating, it may be that there'll only be one or two published studies on it. Certainly novel interventions may lack any replications or consist of just a handful. Associations might be documented, but may vary due to moderators such as personality, individual differences, or socioeconomic and demographic factors. How serious an issue is it? Well, in the study that I've assigned as a reading, what they did was they set out to replicate 100 psychological findings published in the literature. And these weren't ham-fisted attempts with low statistical power. They contacted the original researchers. They made sure that the replications were adequate, that it met sufficient scientific rigor, and if necessary they increased their sample size just to make sure that it wasn't sampling error. Now, out of the 100 that they attempted to replicate, a staggering 61 failed to replicate. So that means only 39 of the 100 studies could be replicated a second time. Now, I don't know about you, but that sounds like bad science. And so it sent shockwaves throughout the psychological community. And these weren't necessarily just clinical studies, they were a variety of psychological effects and associations across general psychology. So we can't say that it's just limited to a particular area. It does appear to be pervasive across all fields of psychology. So if that doesn't give you pause, let's go a little further. If a review that you read about a particular research question is to be trusted, then combining evidence from multiple studies needs to be done in a transparent and objective manner. Because we can't trust a single study, but nor can we trust selective cherry picking. What happened in the past is that narrative reviews would often form different opinions because they were highly selective and often discounted or omitted important research. For example, researcher A includes 5 studies cherry-picked to argue that an effect is small or even trivial. They're barracking for the null hypothesis. Researcher B discounts 2 poor quality studies, which had been included in researcher A, includes 3 more studies that researcher A never looked at, and argues that the effect is large. And then we have the problem of dueling experts. It's hard to arbitrate such decisions, and it means that different practitioners will form very different opinions based on which review they happen to read. They may even be ignorant of the discrepancy between those 2 reviews. So how strong is that evidence? Well, I'd grade that a B-. It's certainly more impressive than a single study, but it is subject to the selectivity and the decision-making of the reviewer. Why is that a problem? Well, hopefully we've all heard of confirmation bias. If you haven't, it's the tendency to interpret, emphasize, or discount information to suit our worldview or our beliefs, to see what we want to see in the body of literature and dismiss those things we don't like or agree with. Now, as psychologist practitioners, we need to be able to demonstrate the efficacy of our interventions, and we're going to be held to a much higher standard than I read it in an article. Narrative reviews used to amount to a tally system, what was called vote counting, and they would argue for the majority viewpoint. But sometimes the majority would be wrong. And so it's important to consider the entire body of literature rather than some cherry-picked studies. So from review to meta-analysis. So the lack of scientific objectivity prompted the need for statistical techniques that could quantify the results across many studies. It led to the development of meta-analysis, which is widely used in psychology and medicine. Psychologists created the technique, and we did it first. And meta-analysis was originally designed to provide this objective evidence rather than the subjective opinion of a narrative reviewer. So, it's certainly looking stronger. Not quite there yet, but we'll get there. So one of the first high-profile meta-analyses was a meta-analysis by Smith and Glass. It combined almost 400 separate studies to evaluate the effect of psychotherapy. And it was a very broad definition of psychotherapy across a variety of disciplines. And it aimed to refute the claim made by Eisnig that 75% of neurotics get better with the passage of time. In other words, that psychology was all smoke and mirrors and we weren't really delivering any benefits to our clients. Now, the meta-analysis by Smith and Glass provided a nice objective measurement to quantify how big of an effect there was between psychotherapy and a control group. And it found a moderately large effect size of D equals 0.68 over controls. Now, if you're not a clinical psychology student, you might be wondering, why do I need to know this? Well, regardless of whether you're an org psych or clinical, psychology would not be regarded as a science without the ability to provide tangible evidence. Now, this first meta-analysis demonstrated the power of that technique for providing objective evidence that people, even in other disciplines, could interpret. But of course, it didn't have to stay with the clinical. It can be widely used for a variety of applications. Now, the goal of meta-analysis is to estimate the size, if any, and we don't go in assuming that we're going to find a meaningful effect. We might well go in and the literature just fails to reject the null hypothesis. So we go in there blind, just looking at the size of the evidence across a variety of studies. Now, existing studies might have small sample sizes. That means that it may lack statistical significance, and many of the original studies, particularly if they're small sample sizes, they may not even be statistically significant individually, but when you pull them together, you have a much bigger sample size and a more objective measurement. Now, the other problem with small sample sizes is that often it leads to effect size inflation. So if you take a correlation between two constructs and you're using a very small sample size, you will tend to have a larger effect or a stronger association than would be obtained from the general population. So a meta-analysis can actually take account of that effect size inflation, and it can pull these studies together. It also gives you a greater chance to refute the null hypothesis than any single study. And it provides greater precision in estimating the effect, as well as its upper and lower bounds. So usually a meta-analysis will provide confidence intervals. Now this is what most consumers of a meta-analysis are interested in. But of course it offers so much more. It goes much beyond that initial effect size. Sadly, most psychologists, I have to admit even those with statistical training like yourselves, will start with the abstract, read the effect size, and then they'll move on. Now, would you buy a used car though without kicking the tyres and checking if you've bought a lemon? I wouldn't. So part of meeting your ethical obligation to provide evidence-based interventions is to understand under what circumstances they are appropriate and when others might be more suitable. So you need to understand moderators. Moderators are incredibly important in meta-analyses, and it's often something that goes overlooked by the typical consumer who unfortunately just starts with the abstract and then moves on. So please do stick around for the next lecture when we'll go through meta-analyses, how to interpret them, and how to make sense of the information on moderators. Now, of course, meta-analyses don't turn out to be the panacea that we'd initially hoped. Meta-analyses is imbued with so much greater trust by scientists, by non-practitioners, by government regulation agencies, but they could still be subject to selective cherry picking. And that cherry picking is incredibly dangerous in science, particularly with confirmation bias. So once a meta-analysis is published, if it's done poorly, and often the initial ones are, it can have a chilling effect on subsequent discourse. That may mean that future researchers decide not to pursue that line of investigation. It may mean that government regulators are more difficult to convince to fund research in that area, and it may mean that an incorrect conclusion is drawn. It's less of an issue of the statistical technique, but more a problem with the comprehensiveness and the quality of the studies it comprises, and in particular the competency of the statistician performing the meta-analysis. So an alternative is to use these meta-analytic techniques to survey instead the entire body of literature in a rigorous, systematic fashion. And that, boys and girls, is where a systematic review comes from. So a systematic review aims to answer a particular research question using all the available literature that match a specific inclusion criteria. Now we do this so we're not admitting garbage studies that are poorly executed or poorly measured. We may have a particular inclusion criteria that we use, and we state this up front so that the reader is informed. Now this is called the review protocol. We'd all like to believe that scientific research is carried out objectively, competently and without bias, but, people, right? We all have our axes to grind. Sometimes we're under pressure to publish, and sometimes we may have greater aspirations than our abilities can meet. So I've left there a link, which is an additional reading about the importance of protocols and being very upfront with the protocol in a systematic review. I will leave that for you to review at your leisure. Now, systematic reviews do this transparently by outlining the initial search strategy to identify potential candidate studies, by specifying the rules for considering the study, and on what grounds they may be excluded. We do this to be transparent so that the reader can determine for themselves whether that criteria is overzealous, particularly the exclusion criteria. It considers all potential sources, not just peer review, so including grey literature, what we would call unpublished studies, so things like honours thesis, master's theses, clinical trials, large randomly controlled trials that perhaps haven't yet been published, but you would be aware of by looking at clinical review registries. And it shows at each stage the number of studies considered and how many were excluded. And that gives the reader an indication of how selective that meta-analysis or that systematic review is. So let's have a look at one of them now. We can see here we have the number of reviews identified through database searching, and often these contain duplicates, so we're whittling them down. Then you see here all of the records were screened. The full text articles assessed for eligibility. Now there's a bit of a drop-off here. And then the number of studies included, so n equals 6. And so it's starting to look like a very selective review here. And I would question the criteria by which they were excluded, and I'd want to have a look at the protocol behind it. Alright, so if they don't do this, despite what the authors may call it, and sometimes an author will call something a systematic review when it really doesn't meet that criteria, unfortunately it ain't a systematic review and it really shouldn't be trusted. So the systematic reviews is A+ standard of evidence. But remember that a meta-analysis or systematic review is only a snapshot of extant literature at a given point in time. Now, if the field is developing, there may be new evidence that emerges, new studies that call into question past findings. It's also the case that new questions may be asked. Maybe you have a look at different outcomes, or that previously unknown moderators are identified in the literature, in which case a systematic review may need to be updated, and you may want to consider then the age of the systematic review or meta-analysis and the context in which it was written. So we have here a nice easy diagram of the evidence hierarchy. Down below, the lower level are anecdotes, hunches, opinions, maybe editorials. We have individual case studies which do provide some benefit, particularly the n equals 1 type case studies. But generally we like to have studies and evidence that is across a large group of participants. Now if it's quasi-experimental, we may go for cohort studies where we follow along at different time periods to try and investigate things like causality, or we may directly experimentally manipulate things in the case of an experimental study, maybe a randomized controlled trial. When we have enough of them, we may produce a meta-analysis, but when the field continually grows and grows and grows at a rapid rate, we may then go and conduct a systematic review. Now, typically a systematic review, though, would incorporate a meta-analytic component. There are, very occasionally, systematic reviews that you'll read that come across more as a narrative review because they lack the statistical proficiency to conduct a meta-analysis. Generally, though, a systematic review will include a meta-analytic component. So I don't want you to take away the view that they're mutually exclusive. A systematic review, and you often see a systematic review and meta-analysis. But there are sometimes systematic quantitative reviews where instead of aggregating the effect sizes and the research findings, they may look at other characteristics of studies. Okay, so down the bottom we have the less trustworthy evidence, and moving up the top we have the more trustworthy evidence. So that's it for this first overview. In the next lecture I'll cover meta-analyses, how to interpret them and how to conduct them.